The purpose of this project is to type two characters into the serial monitor and to have them display on a 14-segment display. The first part of the project is the hardware part. Two shift registers are daisy-chained together. The outputs on the shift registers are tied to the 14-segment display. The transistors take a square wave, turn it on and off the displays to output a PoV effect. The output enable pin, which controls the brightness, is controlled by a potentiometer. The first part of the software part is the code. Of the code is writing the segment maps for the letters to EEPROM. EEPROM is non-volatile storage and is where the segment maps for each letter are stored. As EEPROM can only hold 8 bytes, the segment map is split up with the low byte of the segment map being written 100 addresses above the high byte, which are written at their ASCII values for each letter. For example, A is stored at 65, B is stored at 66. Once the segment maps have been written to EEPROM, the next part of the software is reading the serial monitor and displaying the characters on a 14-segment display. The first part of the code is to initialize the variables for the pins for the shift registers, as well as for the potentiometers that controls the brightness. Next, in void setups, the pins are set up as their respective inputs and outputs, and then the serial set time, which controls how long the serial monitor takes to read the input, is set to 1 millisecond. In the void loop, the first part is reading the values of the potentiometer and mapping them to a value between 0 and 255. After it has been mapped, it is outputted to the shift registers to control the brightness. The next part is reading the serial monitor and splitting up the characters. Is the enter key. If they both are not the enter key, it proceeds. The letters are then checked if they are lowercase. If they are converted to uppercase. And if they're outside the ASCII values of A to Z, it constrains them to the values of A to Z. The bytes are then shifted out with the low byte of the first character being shifted out first, as the shift out function can only shift out 8 bits, then the high byte is shifted. The character that is shifted out has the same value as the segment map in ASCII, and it finds the value. For example, A is at the address of 65, and it finds it, and then it shifts that value out. The switch pin is set high, displaying the first character. The process repeats for the second character, with the switch pin being set low to display the second character.